problem. Later we'll take, when we will do line to line, we'll talk about this. Okay, the solution for this problem is, now what we are having, we have a base value of, on the base we have to choose the base value first, because we have to find the values both in per unit and in the actual values. So we will say, let us consider the base of 20 MV given above. We'll choose that 13.8 kV, 13.8 kV, and we know that voltage is not given, so we will assume that, this is a very important point, EA will be 1 per unit. I have told you this earlier. We have to assume it 1 per unit. Since what? Since the internal voltage will be equal to the terminal voltage at no load. Load is not there, so internal voltage definitely will be of the generator. Internal voltage will be equal to what? Terminal voltage at no load. So this is very important. We have to consider this, because we are not considering, we are always analyzing it on no load, unloaded alternator. Okay, the next what we have, so then in per unit we have already derived this equation. In PU, how we can do it? So we know that in case of line to ground fault, positive sequence current is equal to EA divided by Z1 plus Z2 plus Z0. Now note, in this case, in this question, neutral is not, nothing is referred about the neutral. Sorry, nothing, we don't have a neutral grounded or something else, so we have to leave that 3Z, and we don't have it here, so we don't have to consider that. So this can be written as 1 plus J0, 1.0 plus J0 in case of rectangular. Z1 is J point, it's given here, J.25, J.35, and J.10. J.25 and J.35 and plus J.10. So from this equation we can find IA. The value of IA1 will be minus J1.43, but this value is in per unit. So in line to ground fault, we know that all the sequence currents are same. So IA will be 3IA1. So that will be equal to minus J4.29, but in per unit. Now, base values we have chosen, we'll find the base current. So base current will be, can multiply it, but last time what I've shown formula, or you can do it like this. This is one and the same thing. 2 into 10 to power of 20 into 10 to power of 3. This is base current, MVA divided by under root 3 into 13.8 kV. So we are considering kV. So this is in 10 raised power 3. Sorry, this should be, I think, 20 MVA. This should be 10 raised power 6. That's a mistake. Okay, this can be 10 raised power 3. This is 10 raised power 6. And this value is 837 amps. It will be, this value is 837 amps. So what is the actual value of the subtransient current in line A? This IA. Transient current in line A. So this is the base value, this is the per unit value. That means per unit value multiplied by the base value. So that is J 4.29 multiplied by 837 amps. That will give us J minus of J 3590 amps. So this is the value, actual value we are talking about in amps. Okay, next is, because we know how we have got this, I think per unit value will be actual value divided by the base value. No doubts, there should be no doubts at all. We have to get actual value, this one, per unit value we know, in phase A, base value we know, we multiplied per unit value by the base value, that's all. Okay, next. Next is the symmetrical components of the voltage from point A to ground. That means we have to find the symmetrical component. The symmetrical components of the voltage from point A. That means this is, we are talking about the phase A to ground. They are like this. VA1 we know voltage will be EA multiplied by IAZ1, that we have already derived. EA is 1 minus, so IA1 we have already got, in terms of per unit we'll be writing it, minus J.143, already we have got it. Here you can see minus J.1 multiplied by Z1, that we also know Z1 is, in case of J.25, all the values we know, we can get the value of voltage. VA1 will be equal to 0.643 in per unit. Okay, now VA2, that's a negative sequence voltage, minus IA2 Z2. But in case of line to ground fault, IA1 is equal to IA2 is equal to IA3. All three are same. That's equal to IA by 3. So all the three are same. So we can use IA1 value here. That is minus J 1.43 multiplied by Z2 is 0.35, and that value will come out to be minus 0.50 per unit. Similarly, zero sequence will be minus IA naught Z naught. Minus IA naught is also equal to, all the three sequence current are same. So minus J 1.43 multiplied by J 0.1. So that value will come out to be minus 0.143 per unit. Okay. Next, line to ground voltages. That is phase voltage we are talking about. Line to, these were sequence components. Line to ground voltages. That means phase voltages. Or we'll find that first part is over. We have done that. Who is this joining now? I don't know. Okay. So first part we have done. So line to ground voltages, we can write those line to ground voltage is a phase voltage. That means VAN or VA we write it. V is equivalent to VA1 plus VA2 VA1 plus VA2 plus VA naught is equal to 0.643 minus 0.50. We have already got the sequence voltages. I'm just writing the values 1.43, and that value, if you will check, it should be 0. Why? Because that value should be 0 because fault has occurred in the phase A. Okay, so from that value it has to be 0 because it has grounded. That clarifies that your calculations are correct. So VB will be in terms of VA. In terms of VA naught, it will be plus A square VA1 plus A VA2. That formula we already know. We are going from phase to sequence. That formulas you have to remember. So this will come out to be VA naught is 0.643. I think it is plus or minus. No, VA naught is, I think, 0.643. We have got it correct. That is, I think, VA naught. Just a second. No, it is point. We'll write one by one. I think we have used another values. Okay. Okay, VA naught is what? Minus 0.143 plus then A square is, we will be writing for A square as, you can write a polar value or you can write a rectangular value. A square will be minus 0.5. It's a rectangular value I am writing. You can write 1 at an angle of 240. So into VA1, VA1 is what? VA1 is here 0.643. Okay, and then we have plus, so that value is minus 0.5 plus j 0.866. You have to memorize this rectangular as well as polar A value. Then VA2 is 0.50. So this you have to calculate, and the VB value which you will be getting, VB line to ground voltage from phase B will be equal to, that should be equal to, I'll give the value is minus 2.15 minus j 0.990 in per unit. Okay, then VC, similarly we have to use VC in terms of sequence components of the voltage. So we can use the formula. That formula we know, VA naught plus AVA1 plus A square VA2. So we'll again substitute the values. VA naught is 0.143 minus that, plus A we have to write, A will be minus 0.5 plus J 0.866 into VA1. VA1 is 0.643 plus we have to write A square, that will be minus j 0.866 in terms of rectangular. A square value is this, multiplied by VA2 value we have minus 0.50. So if you calculate this value comes out to be minus 215 plus j 0.990. Almost same what we have got above, but sign differences there, conjugate of each other, VB and VC. Okay, next is we have been asked to find, first we have find positive sequence. What we have been asked to find so line to line voltages for the subtransient condition. So like we are in the phase still now. These are line to ground voltage, that is a phase voltage. Now let's find line to line voltages. Line to line voltages. So line to line voltages are very simple. We know VAB from network, we know VAB is equal to VA minus VB. So that should be 0. Why? 0, no, that should be, sorry, VA is 0, we know that. So that should be minus of this, conjugate what we are getting, minus 2.15 minus j 0.990. VA is 0, we know that. So that will be plus 215 plus j 0.990. So this is all values are in per unit, please make sure. So we can write this in the polar form, 1.01. You have to use your calculators in per unit. Next is VBC from line between line B and C. So that will be VB minus VC. So VB is VB minus VC. You can see what is the value of VB. VB is minus 2, and you can add this to VC. So this and this gets cancelled. Minus 2 point, you have to make it twice. Okay, what is, yeah, just a second. What's the value of VB? Yeah, VC. So you can cancel the conjugates, and why we are getting some different values? Just a second. Okay, VA minus VB, VA is 0. Just a second, let me check the values. I'm getting a different value. Yeah, 0 minus this B, where is B value? Minus, that is fine. We don't have problem with this, issues with this. Okay, VB minus VC. VB is what? Minus 2.15 minus J 0.990 minus VC. So if we make it minus VC, that will be plus 2.15, and that will be minus J 0.990. So plus and plus, this will get cancelled, and we will have a value of I think minus J 1.980 in per unit. That in case of polar can be written as, yeah, fine, in per unit. So similarly, line C to A, VCA can be written as VC minus VA. Okay. So VC minus VA is, what is VC? VC is minus 215 plus J 0.990, and minus VA is 0. So that will be simply same, minus 2.15 plus J 0.990. Okay. This in polar will be equal to 1.01 at an angle of 102.3 degrees in per unit. So we have got the values in line to line values in per unit. Now we have to find the actual values. It is not given in the question, but we need to, in the convention like engineering services examinations or other, where the conventional exams are there, we need to find the actual values also. So please note here, you have to know the generated voltage, to neutral. What is that? That is EA. Considered, because balance voltage are there, was taken as, what was it taken as? It was taken as, so it was taken as 1 per unit. Okay. So the above line to line voltages, are expressed, now they are expressed in per unit, of the base voltages. What are the base voltages? Base voltages are with respect to neutral. So that means base voltage is a phase value. Base voltage is a phase value. It's very important. So above that, line to line voltages are expressed in per unit, but the base voltages, we have considered that as a phase voltages. This is very important point. That means base voltages to neutral. Okay, base voltage to neutral. So therefore, the post fault line voltages are in volts, in kilovolts or volts. In actual value, the post fault voltage will be, so VAB, now you have to see VAB will be what? Per unit value, that is, we are taking magnitude only, or you can take angle also. Per unit, what was 1.01 at an angle of 77.7. So 1.01 at an angle of 77.7 multiplied by Base value is 13.8, but please make sure this base value is a face value. These are line values. So we have to convert that under root, we have to divide it by under root 3. So that value will be 8.05 at an angle of 77.7 degrees kilovolts. So similarly, VBC will be 1.980 at an angle of 270 degrees multiplied by same 13.8 divided by under root 3. Okay. Okay. So then this will be 15.78 and angle 270 degree kV. And then VCA similar grounds will be 1.01 at an angle of 102.3 degrees multiplied by 13.8 under root 3, and that value will be 8.05 at an angle of 102.3 kilovolts. So this is the values you have to find, actual values. So you have to find per unit value. If it is asked per unit, you do this. If it is not asked, neither, this is silent, so you have to find the both values. Just you have to multiply by the base value. Okay, base voltage to neutral you have to multiply, because we are considering this base voltage to neutral. So that is a very important point. We have internal voltage will be equal to terminal voltage. So base voltage to neutral we are considering, that's a face value of the voltage we have to multiply in order to get the actual values. So this was about the numerical, this one. So next we have line to line fault. We'll be doing, after completing all the faults, we'll be doing the gate numericals. Okay, so line to line fault, let's start the line to line fault. Okay, I have here, this is about line to line fault. This is line to line fault. Okay, Moomin is there?
Yes, sir.
Take the log now.
Okay, sir.
Fast, hurry up. Take the log and send it to me. Okay, we'll continue. Line to line fault. Okay, next line to line fault, what we have. See, in this circuit, we have three lines, VA, VB, line to line. This is between A and neutral. This is a phase value. Between lines, this is a line value. So IA, IB, IC are current flowing in the each phases. And then we have neutral point. To the neutral, we have connected a Zn impedance, and neutral current is sum of all the currents. If it is balanced, then neutral current is 0. If it is not balanced, then some value of neutral current will flow, because the currents will not be balanced, that you know. We are considering the fault has occurred in phase B and C. So fault current IF is flowing through an fault impedance ZF. So fault has occurred in phase B and C. So we will be, so that is a line to line fault between phase and C at the terminals of, it should be written here, I will write it in red, unloaded alternator, sorry. Unloaded alternator, that is what analysis we are doing. Okay, this is the diagram. Now B and C we are saying, so let us write down the description, small. Let us assume a line to line fault. Okay, let us assume a line to line fault occurs at the terminals of occurs on, just a second, no need to write this. Occurs, we have to write the name of the phases now, no need this. Occurs on an unloaded alternator between phase B and C, which is very clear from the diagram. Which is very clear from the diagram. So let's write first pre-fault conditions. Yeah, Moomin, what will be the pre-fault conditions? Moomin,
Yes, yes sir.
what will be pre-fault conditions?
सर हमारी जो ये क्या बोलते हैं इसको करंट होगी वो जीरो होगी इन सब में.
Very good. Pre-fault conditions will be same because it's unloaded alternator. So there is no load, so currents will be, all the currents
Zero.
will be zero. IA will be equal to IB will be equal to IC, and that will be equal to 0 amps. What about voltages? VA, VB, VC, R, what are they?
Sir balanced at first.
Yeah, they will be balanced, are balanced voltages. So this is not going to change. Pre-fault conditions, there is no fault, nothing will happen. So next is post-fault conditions. Rutba is there, Rutba? Roll number 5. Okay, Sana
Yes,
is
sir.
there. Rutba.
Yes, sir.
Okay, what are the post-fault conditions now? Have a look at and tell me what are the post-fault conditions. From this portion, you have to tell me the post-fault condition. IA, obviously, there is nothing in happening in the IA phase A, so that will be 0. What will be the other post-fault conditions? Fast, itna time nahi hai. Is Sana is there?
Sir, hello.
Yes,
IB and IC would not be zero.
but I know. But what will be IB and IC equal to? Can apply Kirchhoff's current law here. See, IB is coming this way, IC is coming this way. So if you have to find, IB will be obviously equal to fault current, same direction, but it is in opposite to IC. This is one of the, okay. Second, what will be the third? Okay, Ishfaq, roll number 8. He's not there.
Yes, sir.
What will be the third post fault condition?
IN will be
About
equal to
voltage.
IA.
Oh, that is current has gone. IA is 0. IB is equal to minus IC. That will be equal to fault current. And what about the voltage? Apply the KVL here. This voltage and current.
VB is equal to
Yes.
IC into ZA.
How IC? IC is coming in the opposite direction. What you are talking about? VB
IC minus
minus.
IC
This is
into ZA.
voltage drop. Here is VB. This is VC. So VB minus VC will be IF into ZF. And also we can write this. This can also be written as VB minus VC will be equal to IBZF. So these are, let's call it equation number 1. These are the, you can apply this, see this voltage and this voltage. Voltage across this is VB minus VC. What is the current flowing? IF. That is equal to IB ZF. Simple. So these are the post fault. Whosoever understands this will understand the faults. Otherwise, you'll not be able to understand the faults. किसी को doubt है? Anybody has a doubt? I can again. Okay. I think this is clear. Okay. So this is pre-fault and this is post-fault. Okay. Now moving to next now. Now we know what are the symmetrical components we have. Symmetrical components of the current we know. IA is equivalent to what? IA naught is equivalent to 1 by 3 IA plus IB plus IC. This everybody knows. So IA1 is 1 by 3 IA plus AIB plus A square IC. This we have derived. You have to memorize these. IA2 1 by 3 IA. We are going to symmetrical to phase. So in second, A will come first. If we are going from phase to symmetrical, then A square will come. That's all. IA plus A square IB plus AIC. Let's call it equation number second. Okay. So in this case, what we are going to do, let us apply the conditions. Now, what are the conditions? IA naught will be equal to 0. You can see here, substituting the values of substituting set of equation 1 in equation number 2. This set we have to, so what will be the first case? First case will be IA naught. Let us find this. IA naught is, IA is 0, 1 by 3, IA is 0 plus IB, but we know that IB is equal to fault current, that's equal to IC. So instead of IC, I can write minus IB. So that will be equal to 0. So IA naught will be equal to 0. Let's call it equation number 3. Now let's apply other. So here we will write IA naught is equal to 0. So there will be no zero sequence component in. Therefore, there is no zero sequence component of current in line to line fault. It does not rather exist. So zero sequence component will not be present there. Now let's substitute in other values. So IA1 will be 1 by 3. Okay. IA is 0. Okay, that will go 0. So we will write IAB. So IAIB, operator A into IB current plus instead of IC, I can write minus IB again. So because here we will write A square minus IB. Why I am writing that? Because IC is equal to minus IB from post-fault conditions. We are doing the post-fault analysis. Okay. Now further, I1 can be further written as, I'll take this IB common. So I will write IB by 3 A minus A square. So if I substitute the value of this A minus A square, IB by 3, A is 1 at an angle of 120 degree minus 1 at an angle of 240 degree, or you can use the rectangular polar values, and minus 0.5. Just now we have seen that what was that value. We can substitute that values. So if you solve this, but therefore IA1 will be equal to 1 by 3, okay, this will come out to be under root j under root 3, and IB is also equal to IF. That we know. We can write IF, fault current, because later we'll be calculating the fault current. So under root 3 will come in the denominator. So IF can be written as minus, sorry, this is here. Yeah, this is here. Just a second. Yeah. So when this will under root 3 and this will go on the other side, so we can write it minus j under root 3 into IA1. So in other words, if we have to take the amplitude of this one, we can write under root 3 IA1 at an angle of minus 90 degree. So this is the value of this positive sequence. This is the value of the fault current. Okay, then this value obviously is in the per unit. Let us call it equation number 3. Next we have IA2. IA2, what we have, you can have a look here. IA2 is I is 0, A square IB minus A IB we can write, because IC is equal to minus IB. So we'll write 1 by 3 A square minus A IB. You can write this, and then we can conclude here. See here, this IA1 will be exactly here. You can see this IA1 is exactly minus of this one. If you put a minus sign here, this will be same. So we can write IA1 is minus IA2 is minus IA1. They're just reciprocal of each other in terms of signs. So here IA1 is equivalent to minus IA2. This relationship is also very important while we are deriving the numericals. Next is VB minus VC is IF ZF. We have got this in the boundary conditions. You can have a look here. VB minus VC is IB ZF. IB is equal to IF. I can write this also. It's one and the same thing. So IF ZF. So what is the value of VB in terms of symmetrical components? That is VA naught plus A square VA1 plus A VA2 minus, what is the value of VC? VA naught plus A VA1 plus A square VA2. So that is equal to what? That is equal to IF ZF. Now here we can write VA1, we can write here VA naught and VA naught gets cancelled. VA1 will be A square minus A. VA1 will be A square minus A plus VA2 will be A minus A square, and that should be equal to IF into ZF. So here what we can do, we can keep it like this. VA1 will be A square minus A plus VA2 will be A minus A square, and this I of ZF, we have got the value of the I of ZF earlier, that is equal to under root 3 minus J under root 3, we earlier got it, IA1. I'm substituting the same values what I have got for the IF, IA1 ZF. So further here, so what we'll be doing, this value will come out to be minus J, A square minus A is coming out to minus J under root 3 VA1 plus, and that value is plus J under root 3 VA2, and that value is minus J under root 3 IA1 ZF. So J under root 3 will get cancelled off throughout. So we can have VA1, negative sign will come here, VA1 minus VA2, that should be equal to IA1 into ZF. So let's call it equation number 4. Very important relationships we are getting. So that is equation number I think 5, sorry. Equation 5, we can write down this. Up to here, is there any questions? Moomin?
No, sir, clear.
Okay. Okay. Now, next is interconnection of the sequence diagrams. Last time we have done, or equivalent circuit we also called. So, interconnection sequence network, or we also call it equivalent circuit. Sorry. Okay. Now have a look here. What we have, zero sequence current we don't have here. That is zero. We have seen that. It's zero. Okay, it is zero. This zero sequence current. Okay, when it is zero, that means zero sequence current will not flow. Let me have a reference like this. Before before I will make the connection, before I will go this, I have to make the observations. Okay, let me strike them off. I'll make the observations first, then we'll go further because it will be very clear for us what type of diagram we will have. Okay, Mansha is there, roll number 26.
Yes, sir.
Okay, just a second. Mansha, before drawing the diagram, can you tell me what are the observations we have in line-to-line fault?
So we won't require zero sequence current here because that is equal to 0.
Very good. Next. Just like whatever expressions I have got, you have to tell those conclusions. That's all. Nothing else. I don't expect anything that you have not studied to tell. You will be expressing the same thing what I have not studied. No, whatever I have done in the analysis, whatever we have derived till now, just those are the observations you tell me. Number 1 is correct. Okay, fine. Jaldi time nahi hai Mansha. Please,
Yeah,
beta.
sir, next step would be positive sequence current would be the reciprocal of the negative sequence current.
That is current in terms of, yes, that's correct. Any other? Okay, that's all. This is all very good. Nice. So number 1 from above equations, in case of line-to-line fault, zero sequence component of the current is, number 1 observation is zero sequence component of current is absent. So that is fine. We have done. And positive sequence of the current is equal in magnitude but opposite in phase to negative sequence component of current. Positive sequence component of current, okay, is equal in magnitude but opposite in phase to negative sequence component of current. That is, we have already seen IA1 is equal to minus IA2. Okay, then a bit slightly more. In order to simulate this line-to-line fault, zero sequence network is not required, and positive and negative sequence networks are connected. How they are connected? They are connected in opposition. Why? Because the direction of the currents are opposite. So to simulate line-to-line fault zero sequence network is not required. That we have seen because current is zero. Okay. And second point is the positive and negative sequence networks are to be connected. Yeah, are connected, whatever you want to write, in opposition. Opposition means currents are in opposite direction. Though it will be easy now for you to draw the interconnection of sequence networks. That will be minus IA2. So these are the observations only we had in this case. So let us move to let's move to interconnection of, now it will be very easy for you. Okay, roll number 53, Farhana. Roll number 53. 53.
Yes, sir.
Respond fast, okay? Otherwise, I will remove you from this class. Okay, tell me how we can draw this interconnection of sequence network. We have lots of background noise. I think you are traveling somewhere. Yes, beta, jaldi time nahi hai itna hamare paas. How we can draw this? Where you are traveling in the car? Huh? Okay, fast. Okay, Farhana. मोमिन ये रोल नंबर 11 का नाम नोट करना. रोल नंबर 11. ओके, रोल नंबर 30. तौहीद. रोल नंबर 30. रोल नंबर 30. इसको 30 को एब्सेंट कर देना. ठीक है, नोट डाउन दिस. मोमिन.
Yes, sir.
11, 30 और फरहाना को भी. 29. रोल नंबर 29 इज देयर. उसको भी. ओके, रोल नंबर 71 फरखंदा. 71 फरखंदा. रोल नंबर 71. नोट डाउन इज रोल नंबर आल्सो. मोमिन.
सर, ये हमारी क्लास नहीं, वो सर की कुछ नीड्स थी ना, आपने बोला सर इनको ज्वाइन करने के लिए.
अच्छा, छोड़ो इसको. रोल नंबर 47 को नोट करो. रोल नंबर 47. रोल नंबर 27 को भी नोट करो. ये ओके. रोल नंबर 42. 42.
जी सर, अस्सलाम वालेकुम
जल्दी, टाइम नहीं मेरे पास. इंटरकनेक्शन ऑफ सीक्वेंस नेटवर्क, हाउ वी कैन ड्रॉ. What's the problem? Why you are not understanding the things? इसमें क्या difficult है? Okay, roll number 51, Murtaza.
Yes, sir.
Okay, tell me how to draw this. (48) Diba.
Yes, sir.
रोल नंबर 62 को नोट करो. रोल नंबर 62. मोमिन.
यस सर. क्या?
ये नोट करो आप रोल नंबर्स.
ओके सर.
हाँ, दीबा, टेल मी हाउ टू ड्रॉ दिस इंटरकनेक्शन ऑफ सीक्वेंस नेटवर्क.
सर पहले ग्राउंड होगा,
ओके शाबाश, देन
उसके बाद जेड है,
हाँ
उसके बाद फिर ये
ये तो है ही। कौन से सीक्वेंस ये वोल्टेजेस होंगे? खाली करंट, सीक्वेंस करंट कौन से होंगे और सीक्वेंस वोल्टेज कौन से होंगे? ये इतना आसान है कि सारा कुछ सॉल्व मैंने किया, आई डोंट नो।
पॉजिटिव,
और
सर
पॉजिटिव,
पॉजिटिव और नेगेटिव करंट होगी ना?
okay, that is correct. So they will be in which direction?
ओपोजिट डायरेक्शन।
Okay. आज मुझे एक चेक करने दो. What is the roll number 2 branch change? Arsalan.
Yes, sir.
Roll number 5 Rutba.
Yes, sir.
Roll number 28 Arbaz.
Yes, sir.
Roll number 39 Furqan. 39 Furqan. का नोट करो रोल नंबर. मोमिन.
Yes, sir.
Okay. Roll number 53 Farhana.
Yes, sir.
Why you are not answering them questions? Roll
Sir,
number
मेरे
6
network issue है।
Arshad.
Yes, sir.
Roll number 63 Khawaja Jamshed.
Yes, sir.
Roll number 64 Fazila.
Yes, sir.
67 Irfan.
Yes, sir.
71 Farkhanda is not required. 15 Faisal. इसको नोट करो. मोमिन.
Yes, sir. क्या?
Remove him from our. वो कल से इनका. रोल नंबर 16.
Yes, sir.
रोल नंबर 29.
Yes,
रोल नंबर
sir.
29.
Yes, sir.
मोमिन तो है ही. 26 मंशा भी प्रेजेंट है. इरम. रोल नंबर
Yes,
38.
sir. Yes, sir.
43 नायरा.
Yes, sir.
46 आफरीन.
Yes, sir.
48 दीबा.
Yes, sir.
51 मुर्तजा.
Yes, sir.
56 सिमरा.
Yes, sir.
52
Yes, sir.
असरार.
Yes, sir.
42 दावर.
Yes, sir.
11 फैज.
Yes, sir.
इफाम 31.
Yes, sir.
इल्हाम 21.
Yes, sir.
Okay, Ishfaq is there. 8.
Yes, sir.
Mehnaz 44.
Sir.
Sabia 49.
Yes, sir.
Shahid 1.
Yes, sir.
Shahid Rashid 4.
Sir.
Umar Qadir 3.
Yes, sir.
Yasir 66. Zubair 16. जुबैर. ओके. जो एब्सेंट है उनके नाम मुझे भेज देना अलग से. मुमिन.
Okay, sir. मैं भेजता हूँ.
will not allow them from tomorrow onwards. ठीक है, उनको रहने दो आप एब्सेंट. तो सरप्राइज चेक ये कभी कभी होगा. मैं सोच रहा था तुम सिंसियर स्टूडेंट्स हो, बट okay, let's start the interconnection of as I have talked to. I was asking किसने करेक्ट बोला अभी? रुतबा ने बोला या आंसर करेक्ट किसने बोला अभी? Let's given this correct answer. So this is reference, okay? So we will have a positive sequence, fine. Voltage source will be there and impedance will be there. Okay. Then we have ZF, that is your fault impedance. Then we have negative sequence impedance. Okay. So let me draw the voltage source will be only one, for that will be the positive. Okay. So we will have impedances. Okay, we will have this impedance also. This is Z2, this is Z1. This is EA1. Positive sequence will only have voltage. This is your reference. Okay. This is your field impedance. Fault impedance, sorry. Fault impedance ZF. So This is your ZF. So this between this reference point and this point, this is a voltage VA1. Between this reference point and this reference point, this is a voltage VA2. Okay. So positive sequence current will be flowing like this. This is the direction of positive sequence, and this is the direction of the negative sequence. So positive sequence will be moving like this. So this is IA1, this is IA2, this is IA1, sorry. This is IA1 here, same direction. So this is the interconnection of the sequence networks. Now, further, I hope this is clear. As per the derivation, we are doing it. So if we apply the KVL, applying KVL, IA1, you can see IA1 current we can find. Voltage is EA1 divided by what are the impedances? Zero sequence is missing here. So we have positive, negative, and we have fault impedance. So in this case, zero sequence is not required. So that is the per unit value. I will box it. This value will be in the per unit. Sorry. This is in the per unit value. Okay. If I have to find the fault current in per unit. So what is the value of fault current? You can see fault current is ZF. It is equal to, we have seen the fault current was equal to IF was equal to IB. We have seen that. So we can write for the fault current under root 3 IEA, under root 3 EA1 okay, divided by Z1 plus Z2 plus ZF. Okay, this is fault current. We have seen fault current. You can go to previous page, and above you can see fault current. We have seen IF was equal to under root 3 IA1, magnitude of that one. Angle that doesn't matter for us for time being. Magnitude was equal to this. So we have replaced this by under root 3 IA1 was fault current. Okay, so we have got this under root. Okay, sorry. Yeah, no problem. IA1, what was the value of IA1? IF was equal to, so sorry, I think we have some mistake here. Just a second. You can see here IF. IF very clearly is here. IF very clearly is here under root 3 IA1. Okay, so instead of IF, I will be writing under root 3 IA1. So this will be under root 3 IA1 here. Okay, divided by this impedance. Okay, so this is another equation. Then if we have to find actual value of this fault current, actual, that means in amps, so that will be IF in per unit. This value is again in the per unit only. IF in per unit multiplied by MVA divided by under root 3 into VL. We have seen these derivations before also. So let's call it 6, equation 6. This is 7 and this is 8. Whatever the numbers are there, please check it. So these are three important equations. Next we have short circuit MVA. Actually, should have done that also. Don't have time. We'll see if tomorrow we have to also engage an extra class because we are behind the syllabus. Last week we have missed 1 week. So we'll be continuing with this. Okay. Mumin, अभी आप log भेज दो दोबारा. And mention those absentees